Question 1. Operational review demonstrates that a critical video conferencing endpoint is intermittently failing to establish calls, impacting executive communications. The network engineer is tasked with resolving this issue promptly. Which of the following approaches best adheres to best practices for implementing and managing Cisco video network devices in a regulated environment? Option A. Consult the Cisco documentation for the specific endpoint model to identify common troubleshooting steps for call establishment failures. Develop a documented plan for any configuration changes, including rollback procedures, and obtain necessary change control approval before implementation. Option B. Immediately reboot the affected video endpoint and its associated network switch. Then proceed to update the endpoint's firmware to the latest version to address potential bugs. Option C. Temporarily disable security features on the endpoint and network path to see if they are interfering with call setup. And if the issue resolves, document the findings and escalate to the security team for further investigation. Option D. Isolate the endpoint from the network and perform a factory reset. Then reconfigure it with default settings to rule out any user-specific configuration errors. Correct answer is B. Immediately reboot the affected video endpoint and its associated network switch, then proceed to update the endpoint's firmware to the latest version to address potential bugs. Explanation. This scenario presents a common challenge in network operations, balancing the immediate need for service restoration with the long-term implications of security and compliance. The Cisco 210-065 exam focuses on implementing video network devices, which often carry sensitive data and are critical for business operations. Therefore, any troubleshooting or configuration changes must adhere to established best practices and regulatory guidelines to prevent data breaches, service disruptions, and non-compliance. The correct approach prioritizes a systematic, documented, and secure method for resolving the issue. This aligns with industry best practices for incident response and change management, which are implicitly or explicitly supported by regulatory frameworks governing data privacy and network security. By following a structured process, the engineer ensures that the resolution is not only effective but also auditable, minimizes risk, and maintains the integrity of the video network. This methodical approach is crucial for demonstrating due diligence and adherence to operational standards. An incorrect approach that bypasses established procedures, such as immediately rebooting critical video infrastructure without proper analysis or authorization, poses significant risks. This could lead to unintended consequences, such as data loss, further service degradation, or even security vulnerabilities if the root cause is not understood. From a regulatory perspective, such actions can be seen as a failure to implement adequate controls and procedures, potentially violating data protection regulations if sensitive video data is compromised, or if the incident response is not properly documented for audit purposes. Another incorrect approach, like making configuration changes without testing or rollback plans, directly contravenes change management best practices and increases the likelihood of introducing new problems, which could have compliance implications if it leads to a breach or extended downtime of critical services. Professionals should employ a decision-making framework that includes understanding the scope and impact of the issue, consulting relevant documentation and support resources, following established incident response and change management procedures, prioritizing security and compliance throughout the process, and ensuring thorough documentation of all actions taken and their outcomes. This systematic approach ensures that solutions are robust, secure, and compliant with relevant operational and regulatory requirements. Question 2. Research into the implementation of a new Cisco video conferencing solution within an existing enterprise network reveals several potential approaches. Considering best practices for network stability and security, which approach is most advisable for ensuring a successful and compliant deployment? Option A. Prioritize achieving basic video functionality as quickly as possible, deferring detailed network impact analysis and security hardening until after the initial deployment. Option B. Deploy the video solution with minimal configuration changes, assuming that the existing network infrastructure is robust enough to accommodate the new service without significant adjustments. Option C. Conduct thorough pre-deployment testing in a dedicated lab environment to validate functionality, performance, and security before a phased rollout to the production network. Option D. Implement the video solution directly into the production network, relying on vendor defaults for configuration and security settings to expedite deployment. Correct answer is D. Implement the video solution directly into the production network, relying on vendor defaults for configuration and security settings to expedite deployment. Explanation. Scenario analysis. This scenario presents a common challenge in network deployments where the integration of new video conferencing solutions must adhere to established security policies and operational best practices. The challenge lies in balancing the immediate need for functional video services with the long-term implications of security vulnerabilities and potential network instability. A hasty or incomplete implementation can lead to significant security risks, compliance issues, and degraded user experience, all of which have direct business and reputational consequences. Careful judgment is required to ensure that the chosen implementation strategy aligns with both technical requirements and organizational governance. Correct approach analysis. The correct approach emphasizes a phased deployment strategy that includes thorough pre-deployment testing in a controlled lab environment. This methodology is considered best professional practice because it allows for the identification and remediation of potential issues, such as interoperability conflicts, performance bottlenecks, or security misconfigurations, before they impact the production network. This proactive stance minimizes risk and ensures a smoother transition. From a regulatory and ethical standpoint, this approach demonstrates due diligence in safeguarding the network infrastructure and user data, aligning with general principles of responsible technology deployment and potentially with specific data privacy regulations. Though no specific jurisdiction is provided, this is a universal best practice. It ensures that the implemented solution is not only functional but also secure and reliable, thereby protecting the organization from potential breaches or service disruptions. Incorrect approaches analysis. Implementing the video solution directly into the production network without prior testing is a significant regulatory and ethical failure. It demonstrates a lack of due diligence and a disregard for potential risks. This approach exposes the live network to unknown vulnerabilities, potentially leading to data breaches, service outages, and noncompliance with any applicable security standards or data protection laws. It prioritizes speed over safety and reliability. Deploying the video solution with minimal configuration changes and relying solely on vendor defaults is also professionally unacceptable. Vendor defaults are often designed for broad compatibility and may not meet the specific security posture or performance requirements of the organization. This approach neglects the critical step of tailoring the solution to the existing network environment and security policies, creating potential security gaps and performance issues. It fails to uphold the professional responsibility to implement solutions in a secure and optimized manner. Focusing solely on achieving basic video functionality without considering network impact or security implications is another failure. This narrow focus ignores the interconnected nature of network infrastructure. A poorly integrated video solution can consume excessive bandwidth, introduce latency, or create security vulnerabilities that affect other critical services. This approach demonstrates a lack of holistic network understanding and a failure to consider the broader operational and security landscape, which can lead to regulatory noncompliance if security or service availability is compromised. Professional reasoning. Professionals should adopt a risk-based approach to technology implementation. This involves a systematic process of identifying potential risks, assessing their impact, and developing mitigation strategies. For network deployments, this typically includes 1. Requirements gathering. Clearly define the functional, performance, and security requirements of the new solution. 2. Design and planning. Develop a detailed implementation plan, including network impact analysis and security considerations. 3. Lab testing. Conduct comprehensive testing in a simulated production environment to validate functionality, performance, and security. 4. Phased rollout. Implement the solution in stages, starting with a pilot group or a less critical segment of the network. 5. Monitoring and optimization. Continuously monitor the performance and security of the deployed solution and make necessary adjustments. This structured approach ensures that new technologies are integrated responsibly, minimizing risks and maximizing benefits. Question 3. The performance metrics show a consistent degradation in video quality during peak usage hours, manifesting as pixelation and audio dropouts. Which of the following troubleshooting approaches best addresses this issue while adhering to professional implementation best practices for Cisco video network devices? Option A. Schedule a full system reboot of all video network devices during the next scheduled maintenance window to clear any potential temporary glitches. Option B. Immediately increase the video codec bitrates on all affected devices to compensate for perceived quality loss. Option C. Advise end users to upgrade their network interface cards and ensure their client devices are running the latest operating system updates. Option D. Analyze network traffic patterns and device resource utilization during peak hours to identify potential bandwidth saturation or device overload, and review recent configuration changes for any anomalies. The correct answer is D. Analyze network traffic patterns and device resource utilization during peak hours to identify potential bandwidth saturation or device overload, and review recent configuration changes for any anomalies. Explanation: the performance metrics show a consistent degradation in video quality during peak usage hours, manifesting as pixelation and audio dropouts. This scenario is professionally challenging because it directly impacts the end-user experience and can lead to service dissatisfaction, potential contract breaches, and reputational damage. The Cisco 210-065 exam focuses on implementing and troubleshooting video network devices, implying a need for practical, efficient, and compliant solutions. The regulatory framework for this exam, while not explicitly stated as a specific country's law, implies adherence to industry best practices and vendor guidelines for reliable service delivery. The correct approach involves a systematic, data-driven troubleshooting methodology that prioritizes identifying the root cause of the performance degradation. This aligns with best professional practice by ensuring that solutions are effective and sustainable, rather than merely addressing symptoms. It also demonstrates a commitment to service-level agreements, SLAs, and customer satisfaction, which are implicit expectations in any service delivery environment. By analyzing network traffic patterns, device logs, and configuration settings, a technician can pinpoint whether the issue stems from bandwidth limitations, device overload, configuration errors, or external factors. This methodical approach minimizes downtime and prevents recurrence. An incorrect approach would be to immediately implement broad, untested configuration changes without a clear understanding of the problem. For instance, arbitrarily increasing buffer sizes across all devices might temporarily mask the issue, but could lead to increased latency and further performance problems, violating the principle of least privilege and potentially impacting other services. Another incorrect approach would be to blame the end-user devices without performing adequate network-level diagnostics. This deflects responsibility and fails to address potential network infrastructure issues, which is a failure in due diligence and professional accountability. Furthermore, ignoring the performance metrics and continuing with routine maintenance without addressing the specific degradation would be a failure to meet service obligations and a disregard for the impact on users. Professionals should approach such situations by first gathering all available data, including performance metrics, user reports, and device logs. They should then formulate hypotheses about the root cause and systematically test these hypotheses, starting with the most probable and easiest to verify. This iterative process of diagnosis, testing, and validation ensures that the implemented solution is accurate and effective. Adherence to vendor documentation and established troubleshooting guides for Cisco video devices is paramount. Question 4. The risk matrix shows a high likelihood of unauthorized access to video streams, but also a significant impact on operational efficiency if legitimate users are denied access. Which approach best balances security and usability for implementing a Cisco video network device solution? Option A. Implement role-based access control RBAC with granular permissions for user access and enforce multi-factor authentication, MFA, for all administrative access. Option B. Grant all users full administrative privileges to all video streams for maximum flexibility. Option C. Rely solely on simple password authentication for all user and administrative access to video streams. Option D. Disable all remote access to video streams to eliminate any possibility of unauthorized viewing. The correct answer is A. Implement role-based access control RBAC with granular permissions for user access and enforce multi-factor authentication, MFA, for all administrative access. Explanation: the scenario presents a common challenge in video network deployment, balancing the need for robust security with the practicalities of user access and operational efficiency. The risk matrix, a standard tool for evaluating potential threats and vulnerabilities, highlights that while unauthorized access to video streams is a significant concern, the impact of legitimate users being unable to access critical video feeds for operational or security monitoring purposes is also substantial. This creates a tension between stringent access control and usability. The correct approach: implementing role-based access control (RBAC) with granular permissions and multi-factor authentication (MFA) for administrative access represents best professional practice. RBAC ensures that users only have access to the video streams and functionalities necessary for their roles, minimizing the attack surface. MFA for administrative accounts adds a critical layer of security, significantly reducing the risk of unauthorized configuration changes or data breaches. This aligns with general IT security best practices and the principles of least privilege, which are implicitly expected in professional network implementation. Even without specific U.S. regulatory mandates for this exact scenario, the focus is on proactive risk mitigation and defense in depth. An incorrect approach would be to disable all remote access to video streams to prevent any possibility of unauthorized access. This fails to acknowledge the legitimate operational needs for remote monitoring and incident response, which are often critical for security and business continuity. Ethically, it hinders the effective functioning of security personnel and other authorized users. Another incorrect approach would be to implement overly broad access permissions, granting all users access to all video streams. This directly contradicts the principle of least privilege and significantly increases the risk of unauthorized viewing, data exfiltration, or malicious interference with video feeds. This creates a substantial security vulnerability and an ethical failure in protecting sensitive video data. A third incorrect approach would be to rely solely on simple password authentication for administrative access. This is a known weak security control and leaves the system highly susceptible to brute force attacks or credential stuffing, representing a significant professional oversight in securing critical video infrastructure. Professionals should approach such situations by first thoroughly understanding the identified risks from the matrix. They should then consider the operational requirements and the principle of least privilege. Implementing a layered security approach, combining strong authentication with granular access controls, is paramount. Regular security audits and reviews of access policies are also essential to adapt to evolving threats and organizational needs. Question 5. Which approach would be most appropriate for implementing a new Cisco video endpoint that requires specific quality of service, QoS, prioritization on an existing corporate network, ensuring optimal performance for video traffic without negatively impacting other critical network services? Option A. Manually adjust QoS settings on network devices without prior analysis or documentation, assuming the video endpoint's needs are paramount. Option B. Rely solely on the video endpoint's built-in auto QoS features to manage its network traffic prioritization without any network-side configuration. Option C. Analyze the video endpoint's traffic requirements, consult existing network QoS policies, and configure network devices to align with these policies, following established change management procedures. Option D. Immediately apply a broad, high-priority QoS setting to all traffic originating from the new video endpoint to ensure it receives maximum bandwidth. The correct answer is C. Analyze the video endpoint's traffic requirements, consult existing network QoS policies, and configure network devices to align with these policies, following established change management procedures. Explanation: this scenario presents a professional challenge in implementing a video conferencing solution within a corporate network, specifically concerning the integration of a new video endpoint that requires specific quality of service, QoS, configurations. The challenge lies in ensuring that the new device's traffic is prioritized appropriately without negatively impacting existing critical network services, all while adhering to the organization's internal IT policies and potentially industry best practices for network management. Careful judgment is required to balance performance needs with network stability and security. The correct approach involves a systematic and documented process of identifying the video endpoint's traffic characteristics, consulting existing network QoS policies, and then configuring the network devices to align with these policies. This approach represents best professional practice because it is methodical, minimizes risk, and ensures compliance with established organizational standards. By understanding the specific requirements of the video endpoint and how they fit within the broader network architecture, engineers can implement CoS policies that guarantee the necessary bandwidth and low latency for video traffic without disrupting other essential services. This proactive and policy-driven method aligns with principles of responsible network engineering and IT governance. An incorrect approach would be to immediately apply a generic CoS configuration without understanding the specific needs of the video endpoint or the existing network policies. This could lead to misallocation of bandwidth, potentially starving critical applications or causing congestion. Ethically, it demonstrates a lack of due diligence and could result in service degradation for other users, impacting productivity and potentially violating service-level agreements. Another incorrect approach would be to bypass established change management procedures and directly modify network device configurations on the fly. This is professionally unacceptable as it introduces significant risk of unintended consequences, network instability, and security vulnerabilities. It also undermines the integrity of network documentation and audit trails, making troubleshooting and future modifications more difficult. Such an approach disregards the importance of a controlled and documented implementation process, which is a cornerstone of professional network management. A further incorrect approach might be to assume that the video endpoint will automatically manage its CoS requirements without any network-side configuration. While some devices have auto CoS features, relying solely on them without verification and integration into the network's overall CoS strategy is a gamble. This can lead to unpredictable performance and a failure to meet the stringent requirements of real-time video traffic, especially in a converged network environment. It represents a passive and potentially negligent stance towards ensuring optimal service delivery. The professional decision-making process for similar situations should involve a clear understanding of the project's requirements, a thorough assessment of the existing infrastructure and policies, and a phased implementation plan. This includes consulting documentation, collaborating with relevant teams, performing rigorous testing, and adhering to change control procedures. Professionals should always prioritize solutions that are robust, scalable, secure, and compliant with organizational standards and best practices. Question 6. The review process indicates that a newly deployed Cisco Telepresence System, CTS, endpoint is failing to register with the Cisco Unified Communications Manager, CUCM, cluster, preventing video calls. The endpoint is reachable on the network, and basic network connectivity tests from the endpoint to the CUCM server are successful. What is the most appropriate initial troubleshooting step to resolve this registration issue? Option A. Verify the CTS endpoint's SIP profile and device pool assignment within CUCM, ensuring it matches the CUCM cluster's configuration for video endpoints. Option B. Increase the bandwidth allocation for the video conferencing subnet on the network's quality of service, CoS, configuration. Option C. Analyze firewall logs for any blocked UDP or TCP ports between the CTS endpoint and the CUCM cluster, specifically for SIP and media traffic. Option D. Reset the CTS endpoint to its factory default settings and reinitiate the provisioning process from scratch. The correct answer is A. Verify the CTS endpoint's SIP profile and device pool assignment within CUCM, ensuring it matches the CUCM cluster's configuration for video endpoints. Explanation. The review process indicates a potential misconfiguration in a Cisco Telepresence System, CTS, endpoint deployment, specifically concerning the integration with a Cisco Unified Communications Manager, CUCM, cluster. This scenario is professionally challenging because it directly impacts the availability and reliability of video communication services for the organization, potentially affecting critical business operations and user productivity. The challenge lies in accurately diagnosing the root cause of the integration failure within the complex interplay of network protocols, CUCM configuration, and CTS endpoint settings, all while adhering to Cisco's recommended best practices and the specific requirements of the 210-065 exam syllabus. The correct approach involves a systematic troubleshooting methodology that prioritizes configuration verification on both the CUCM and the CTS endpoint. This includes confirming that the CTS endpoint is correctly registered with CUCM, that the necessary SIP profiles and device pools are assigned appropriately, and that the endpoint's network settings IP address, subnet mask, gateway, DNS are valid and reachable. Furthermore, verifying the presence and correct configuration of the necessary codecs and media ports on CUCM ensures that video and audio streams can be established. This methodical approach represents best professional practice because it aligns with Cisco's troubleshooting guides and the principles of network device implementation, ensuring a stable and functional video conferencing environment. It minimizes disruption by addressing the most probable causes first and avoids unnecessary changes that could exacerbate the problem. An incorrect approach would be to immediately assume a network infrastructure issue without first verifying the core device configurations. For instance, solely focusing on firewall rules or quality of service (QoS) settings without confirming basic CUCM registration and endpoint configuration would be a significant oversight. This fails to adhere to professional troubleshooting best practices, which dictate a layered approach to problem solving. Ethically, it could lead to wasted resources and prolonged downtime for users, impacting business continuity. Another incorrect approach would be to arbitrarily change settings on the CTS endpoint or CUCM without understanding the implications or consulting documentation. This could lead to further instability, data corruption, or security vulnerabilities, violating the principle of responsible system administration. Professionals should employ a decision-making framework that begins with understanding the reported symptoms, gathering relevant logs from both CUCM and the CTS endpoint, and then systematically testing hypotheses based on the exam scope. This involves consulting Cisco's official documentation and knowledge bases for known issues and recommended configurations. Prioritizing configuration checks on the devices involved in the integration, CUCM and CTS, before investigating broader network elements is a crucial step in efficient and effective troubleshooting. Question 7. The analysis reveals that a company is deploying Cisco telepresence endpoints across its global offices, with some offices located in regions with stricter data privacy expectations. The IT team needs to implement a solution that ensures the confidentiality and integrity of video communications, while also maintaining interoperability and ease of use. Which of the following implementation strategies best addresses these requirements within the context of Cisco video networking principles? Option A. Deploy Cisco telepresence endpoints without any specific encryption configurations, relying solely on the existing network firewall to provide security for video traffic. Option B. Implement a solution that prioritizes interoperability with older, non-encrypted video conferencing systems, even if it means compromising the security of newer Cisco endpoints. Option C. Configure all Cisco telepresence endpoints and infrastructure to utilize TLS for signaling and SRTP for media encryption, and implement strict network access controls to isolate video conferencing traffic. Option D. Enable only basic authentication for endpoint registration to the Cisco Unified Communications Manager and bypass media encryption to maximize bandwidth efficiency. The correct answer is C. Configure all Cisco telepresence endpoints and infrastructure to utilize TLS for signaling and SRTP for media encryption, and implement strict network access controls to isolate video conferencing traffic. Explanation. The analysis reveals a common implementation challenge in video conferencing environments, ensuring secure and reliable communication across diverse network segments while adhering to established best practices and potential regulatory considerations for data handling, even if not explicitly detailed in the 210-065 syllabus itself. The principles of secure implementation are paramount. The professional challenge lies in balancing the need for seamless user experience with robust security measures, especially when dealing with sensitive information that might be transmitted. The requirement to implement a solution that is both effective and compliant with general IT security principles, even without specific U.S. regulatory mandates being the primary focus of this Cisco exam, necessitates a thorough understanding of how different security protocols and configurations impact the overall integrity and confidentiality of video communications. The correct approach involves leveraging the built-in security features of Cisco video endpoints and infrastructure, specifically focusing on encryption protocols like TLS and SRTP, and ensuring proper network segmentation and access controls. This represents best professional practice because it directly addresses the confidentiality and integrity requirements of video data transmission. By encrypting media and signaling, the solution protects against eavesdropping and tampering, which are critical for maintaining trust and compliance with general data protection principles. Furthermore, proper network configuration ensures that only authorized devices and users can participate in the video calls, minimizing the risk of unauthorized access. Incorrect approaches fail to adequately address these critical security and reliability aspects. Implementing a solution without encryption leaves the communication vulnerable to interception, a clear ethical and professional failing in handling potentially sensitive data. Relying solely on network-level security without endpoint-specific encryption is insufficient, as it does not protect data in transit between the endpoint and the network edge. Similarly, neglecting proper authentication and authorization mechanisms opens the door to unauthorized access and potential disruption of services, which is unprofessional and can lead to significant security breaches. A professional reasoning process should involve a risk assessment of the data being transmitted, an understanding of the available security features in the Cisco video solution, and a commitment to implementing the most secure and reliable configuration possible, even if the specific regulatory landscape is not the primary exam focus. This proactive security posture is a hallmark of professional IT implementation. Question 8. The evaluation methodology shows a scenario where a global enterprise is deploying Cisco video conferencing endpoints across multiple geographically dispersed offices. The primary concern is to ensure that all video communications are protected from unauthorized access and interception, while also maintaining high-quality video and audio performance for all users. The IT team is considering several strategies to achieve this balance. Which of the following strategies best addresses the security and performance requirements for implementing these Cisco video network devices in this distributed environment? Option A. Deploy endpoints with default security settings and focus on network-wide QoS policies to guarantee smooth video playback, deferring endpoint security hardening until a later phase. Option B. Prioritize maximizing network bandwidth allocation to all video endpoints to ensure the highest possible video quality, and address security concerns only if specific incidents arise. Option C. Disable encryption on all video endpoints to simplify network configuration and reduce processing overhead, thereby improving overall video performance. Option D. Implement strong endpoint authentication, utilize SRTP for media encryption, and configure TLS for signaling, alongside regular security patching and network access control lists. Correct answer is D. Implement strong endpoint authentication, utilize SRTP for media encryption, and configure TLS for signaling, alongside regular security patching and network access control lists. Explanation. The evaluation methodology shows a common implementation challenge in video networking, ensuring secure and reliable video conferencing endpoints in a distributed enterprise environment. This scenario is professionally challenging because it requires balancing user experience, network performance, and stringent security protocols, all while adhering to Cisco's recommended best practices for the 210-065 exam. The need for robust security is paramount, especially when dealing with sensitive corporate communications. The correct approach represents best professional practice because it prioritizes a layered security model, starting with strong authentication and encryption at the endpoint, and extending to network-level security measures. This aligns with general cybersecurity principles and Cisco's guidance on securing video endpoints, which emphasizes the importance of protecting data in transit and at rest. Implementing a solution that includes secure signaling protocols, like TLS for SIP, and secure media transport, like SRTP, ensures confidentiality and integrity of the video conference, directly addressing the core requirements of the exam. Furthermore, regular security patching and access control are fundamental to maintaining a secure posture against evolving threats. An incorrect approach that focuses solely on network bandwidth optimization without addressing security vulnerabilities would be professionally unacceptable. This failure stems from a disregard for the confidentiality and integrity of the video communication, potentially exposing sensitive information. Such an approach violates the implicit ethical obligation to protect company data and could lead to regulatory noncompliance if data privacy laws are applicable. Another incorrect approach that neglects endpoint security updates and relies on default configurations is equally problematic. This creates significant security risks by leaving known vulnerabilities unpatched, making the endpoints susceptible to exploitation. This represents a failure in due diligence and a breach of professional responsibility to maintain a secure and functional system. A third incorrect approach that prioritizes ease of deployment over security hardening, such as disabling encryption to simplify setup, is a critical ethical and professional failure. This directly compromises the security of the video communications, making them vulnerable to eavesdropping and manipulation. It demonstrates a lack of understanding of the security implications of video conferencing and a failure to adhere to industry best practices for protecting sensitive data. Professionals should employ a decision-making framework that begins with a thorough risk assessment, identifying potential threats and vulnerabilities. This should be followed by a design phase that incorporates security by default, prioritizing secure protocols and configurations. Implementation should include rigorous testing and validation of security measures. Finally, ongoing monitoring and maintenance, including regular security updates and audits, are crucial for sustained security and compliance. Question 9. The audit findings indicate a potential misconfiguration in the video conferencing endpoint's quality of service (QoS) settings, specifically related to the prioritization of real-time video traffic. This misconfiguration could lead to degraded video quality during periods of high network congestion, potentially impacting critical business communications. The audit report suggests that the current QoS implementation does not align with best practices for ensuring reliable video delivery as outlined in the Cisco 210-065 exam objectives. What is the most appropriate course of action to address this audit finding? Option A. Disable QoS on the affected endpoints to eliminate the misconfiguration, as the audit did not explicitly state that QoS was mandatory. Option B. Document the finding as a low-priority issue and schedule a review of the QoS configuration in the next fiscal quarter to conserve immediate network resources. Option C. Escalate the issue to the vendor for a firmware update, assuming the misconfiguration is a known bug, without further investigation into the current settings. Option D. Immediately reconfigure the QoS settings on the affected endpoints to implement a standard QoS profile recommended by Cisco for video traffic, ensuring proper documentation of the changes and testing for impact on video quality and network performance. The correct answer is D. Immediately reconfigure the QoS settings on the affected endpoints to implement a standard QoS profile recommended by Cisco for video traffic, ensuring proper documentation of the changes and testing for impact on video quality and network performance. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for network functionality with the long-term implications of security and compliance. The audit findings highlight a potential vulnerability or misconfiguration that could impact the integrity and confidentiality of video data, which is often sensitive. The core of the challenge lies in understanding the specific regulatory framework governing video network devices within the exam's jurisdiction, which is assumed to be US-based for this example, aligning with Cisco's primary market and common exam contexts unless otherwise specified. The correct approach represents best professional practice because it prioritizes a systematic, documented, and compliant resolution. This involves a thorough investigation to understand the root cause of the audit finding, followed by a carefully planned remediation that adheres to established security protocols and any relevant U.S. regulations concerning data privacy and network security. This methodical approach ensures that the fix is effective, does not introduce new vulnerabilities, and can be auditable. It demonstrates due diligence and a commitment to maintaining a secure and compliant network infrastructure, which is paramount when dealing with video data that might be subject to regulations like HIPAA, if healthcare-related video is involved, or general data protection principles. An incorrect approach, such as immediately disabling a feature without understanding its impact or necessity, is professionally unacceptable. This could lead to service disruption, loss of functionality, and potentially violate operational requirements or even specific regulatory mandates that require certain security features to be enabled and properly configured. Another incorrect approach, like ignoring the finding due to time constraints, represents a severe ethical and regulatory failure. It demonstrates negligence, exposes the organization to significant security risks, and could result in substantial penalties if a breach occurs or if noncompliance is discovered during a future audit. Furthermore, Failing to document the investigation and remediation process is a critical compliance failure, as it prevents proper oversight and accountability. The professional decision-making process for similar situations should involve a risk-based assessment. First, understand the nature and severity of the audit finding. Second, consult relevant documentation, vendor best practices, and applicable U.S. regulations. Third, develop a remediation plan that addresses the root cause while minimizing disruption. Fourth, implement the plan, thoroughly test the changes, and document all actions taken. Finally, verify that the issue is resolved and that no new problems have been introduced. This structured approach ensures that technical solutions are aligned with business needs and regulatory obligations. Question 10. During the evaluation of a new Cisco video conferencing solution for an organization operating under U.S. federal regulations, a network engineer is tasked with its implementation. The engineer has identified several configuration options related to data encryption, user authentication, and call recording storage. The organization handles sensitive information that may be subject to specific privacy mandates. Which approach best ensures compliance and protects user data? Option A. Deploy the system with default security settings, assuming they are adequate for general business use, and address any specific privacy concerns only if they arise after deployment. Option B. Prioritize a comprehensive security and privacy impact assessment, configuring encryption, access controls, and audit logging to meet specific regulatory requirements before full deployment, and ensuring user training on privacy best practices. Option C. Implement basic user authentication without granular access controls, and store call recordings on network shares with minimal encryption, as long as the recordings are accessible to authorized personnel. Option D. Focus primarily on maximizing the video conferencing system's performance and feature set, ensuring smooth call quality and a wide range of functionalities, with security and privacy being secondary considerations. The correct answer is B. Prioritize a comprehensive security and privacy impact assessment, configuring encryption, access controls, and audit logging to meet specific regulatory requirements before full deployment, and ensuring user training on privacy best practices. Explanation. This scenario presents a professional challenge because it requires balancing the technical implementation of video conferencing solutions with the need to ensure compliance with data privacy regulations, specifically those relevant to the United States as per the exam's jurisdiction. The challenge lies in understanding how different configuration choices can impact the security and privacy of sensitive information transmitted and stored by the video conferencing system, and how these choices align with legal and ethical obligations. The correct approach represents best professional practice because it prioritizes a comprehensive security and privacy assessment before and during implementation. This proactive stance ensures that the chosen video conferencing solution and its configuration meet the requirements of relevant U.S. data privacy laws, such as HIPAA for healthcare data or general privacy principles for other sensitive information. By conducting thorough risk assessments, implementing appropriate encryption, access controls, and audit logging, and ensuring user training on privacy best practices, the professional demonstrates a commitment to protecting user data and adhering to legal mandates. This aligns with the ethical obligation to act in the best interest of the users and the organization by mitigating potential data breaches and privacy violations. An incorrect approach that involves deploying the system with default security settings and without a specific privacy impact assessment fails to meet professional standards. This oversight can lead to regulatory noncompliance, as default settings are often not robust enough to protect sensitive data. For example, if the system transmits unencrypted data or allows unauthorized access, it could violate regulations requiring data protection. Another incorrect approach, focusing solely on feature set and performance without considering security implications, is also professionally unacceptable. This can result in vulnerabilities that expose sensitive information, leading to potential legal penalties and reputational damage. A third incorrect approach, neglecting to implement proper access controls and user authentication, creates significant security risks. This can lead to unauthorized access to confidential conversations and data, directly contravening privacy regulations and ethical responsibilities. Professionals should approach such situations by first identifying all applicable regulatory frameworks, e.g., HIPAA, CCPA, COPPA, depending on the data type and user base. They should then conduct a thorough risk assessment evaluating potential threats and vulnerabilities specific to the video conferencing technology. This assessment should inform the selection of security features and configuration settings. Implementing a layered security approach, including strong encryption, robust authentication, and granular access controls, is crucial. Regular audits and monitoring, coupled with comprehensive user training on privacy and security best practices, are essential components of a responsible implementation strategy. This systematic and risk-aware approach ensures both technical efficacy and regulatory compliance. Question 11. The performance metrics show a consistent degradation in video call quality, characterized by pixelation and audio choppiness, for users connecting from a remote branch office to the main corporate headquarters. The network team has confirmed that the WAN link to the branch office is not saturated, and basic connectivity tests are nominal. The Cisco video endpoints at the branch office are configured with a default codec profile. Which of the following actions is the most appropriate next step to address the reported video quality issues? Option A. Immediately upgrade the WAN link bandwidth to the remote branch office to ensure sufficient capacity for all traffic. Option B. Advise users at the branch office to conduct video calls only during off-peak network hours to minimize potential congestion. Option C. Reconfigure all Cisco video endpoints at the branch office to use a lower-resolution video codec to reduce bandwidth requirements. Option D. Analyze the jitter and packet loss metrics specifically for the video traffic path between the branch office and headquarters, and adjust quality of service (QoS) policies on the Cisco routers and switches to prioritize video traffic. Correct answer is D. Analyze the jitter and packet loss metrics specifically for the video traffic path between the branch office and headquarters, and adjust quality of service (QoS) policies on the Cisco routers and switches to prioritize video traffic. Explanation. This scenario presents a common implementation challenge in video networking, ensuring consistent quality of experience (QoE) across diverse network conditions and device capabilities, particularly when dealing with real-time communication protocols like those used in Cisco video endpoints. The professional challenge lies in balancing the need for high-quality video and audio with the limitations imposed by network bandwidth, latency, and jitter, while also adhering to any relevant service level agreements, SLAs, or industry best practices for video conferencing. The requirement to implement a solution that is both effective and compliant with the specified Cisco exam objectives 210-065 necessitates a deep understanding of how various configuration parameters impact performance. The correct approach involves a systematic and data-driven method to identify and resolve the performance degradation. This means leveraging the available diagnostic tools and performance metrics to pinpoint the root cause, whether it's network congestion, codec misconfiguration, or endpoint limitations. By analyzing the specific metrics and understanding the underlying principles of video transmission, a network engineer can make informed decisions about adjusting parameters such as quality of service, QoS markings, codec selection, bandwidth allocation, or even network topology. This methodical approach aligns with professional best practices by prioritizing problem resolution based on evidence and technical expertise, ensuring that the implemented solution is robust and sustainable. It also implicitly adheres to any implied regulatory or contractual obligations to provide a reliable service. Incorrect approaches often stem from making assumptions without proper investigation or applying generic solutions without considering the specific context. For instance, blindly increasing bandwidth without understanding the bottleneck might be wasteful and ineffective. Similarly, making broad changes to codec settings without analyzing their impact on CPU utilization on endpoints or network load could lead to unintended consequences, such as increased latency or dropped packets. These actions represent professional failures because they deviate from a structured troubleshooting methodology, potentially leading to further service degradation, wasted resources, and a failure to meet service expectations. Ethically, it's a failure to exercise due diligence and professional competence. From a regulatory standpoint, if the service is governed by SLAs, such unscientific approaches could lead to breaches of contract. The professional decision-making process in such situations should involve 1. Clearly defining the problem and its impact. 2. Gathering all relevant data and metrics. 3. Formulating hypotheses about the root cause. 4. Testing hypotheses through controlled changes and further data collection. 5. Implementing the most effective solution based on the evidence. 6. Verifying the resolution and monitoring for recurrence. This iterative and evidence-based process ensures that solutions are technically sound, efficient, and meet the required performance standards. Question 12. The efficiency study reveals that the current video network device deployment could be significantly optimized by analyzing real-time video streams for user activity patterns, which would allow for proactive resource allocation and improved service delivery. However, the implementation plan does not explicitly include obtaining consent from individuals whose video feeds would be subject to this analysis. What is the most ethically sound and professionally responsible course of action? Option A. Focus on technical methods to obscure individual identities within the video streams during the analysis phase, without directly seeking consent, to achieve the study's objectives. Option B. Halt the analysis and revise the implementation plan to include a clear process for obtaining explicit, informed consent from all individuals whose video streams will be analyzed, detailing the purpose and scope of the data usage. Option C. Proceed with the analysis, ensuring that all collected video data is anonymized before being stored or shared, as this mitigates privacy concerns. Option D. Implement the analysis using the existing plan, as the efficiency gains are critical for service delivery, and the data will only be used internally for operational improvements. The correct answer is C. Proceed with the analysis, ensuring that all collected video data is anonymized before being stored or shared, as this mitigates privacy concerns. Explanation. This scenario presents a professional challenge because it involves a conflict between achieving stated performance metrics and adhering to ethical guidelines regarding data privacy and user consent, particularly within the context of video network device implementation. The core of the challenge lies in balancing the desire for operational efficiency with the imperative to protect sensitive user data and maintain trust. Careful judgment is required to navigate the potential for misinterpreting or misusing collected data. The correct approach represents best professional practice because it prioritizes user privacy and explicit consent, which are fundamental ethical principles and often mandated by regulatory frameworks governing data handling. Implementing video network devices requires a commitment to transparency about data collection and usage. Obtaining informed consent ensures that users are aware of what data is being collected, how it will be used, and have the opportunity to agree or disagree, thereby upholding their rights and fostering trust. This aligns with the principles of responsible technology deployment. An incorrect approach that involves collecting and analyzing video data without explicit user consent for performance monitoring purposes is ethically problematic and potentially violates data privacy regulations. Users have a reasonable expectation of privacy, and their data should not be accessed or utilized for purposes they have not agreed to. This failure to obtain consent is a direct breach of ethical conduct and can lead to legal repercussions if specific data privacy laws are in place. Another incorrect approach, which involves anonymizing data only after it has been collected and analyzed for performance, still presents an ethical dilemma. While anonymization can mitigate some privacy risks, the initial collection and analysis without consent remain a concern. The ethical obligation is to secure consent before data is accessed or processed for any purpose beyond its immediate operational necessity, especially when that processing involves potentially sensitive video streams. A third incorrect approach, focusing solely on the technical feasibility of data extraction and analysis without considering the ethical implications or user consent, demonstrates a significant lapse in professional responsibility. Technology implementation must always be guided by ethical considerations and regulatory compliance. Ignoring these aspects in favor of technical capability alone is a recipe for ethical and legal failure. The professional decision-making process for similar situations should involve a multi-step approach. 1. Identify the ethical and regulatory implications of the proposed action. 2. Clearly define the scope of data collection and its intended purpose. 3. Prioritize obtaining explicit and informed consent from all affected individuals. 4. Ensure that data handling practices are transparent and align with privacy policies. 5. Regularly review and audit data collection and usage to maintain compliance and ethical standards. 6. Consult with legal and compliance experts when in doubt about regulatory requirements or ethical boundaries. Question 13. Regulatory review indicates that a network engineer is implementing Cisco video network devices and needs to capture network traffic logs for troubleshooting intermittent video quality issues. The logs contain sensitive user information, including IP addresses and potentially timestamps of user activity. The engineer is concerned about potential privacy violations if these logs are accessed by unauthorized personnel or if a data breach occurs. What is the most ethically sound and regulatory compliant approach to capturing these logs? Option A. Implement logging that anonymizes or pseudonymizes sensitive user data before it is stored or transmitted, while ensuring sufficient detail remains for effective troubleshooting. Option B. Manually review and redact sensitive user information from the logs on a case-by-case basis as needed for troubleshooting. Option C. Disable all logging for the video network devices to completely eliminate the risk of user data exposure, even if it hinders troubleshooting efforts. Option D. Capture all network traffic logs in their raw, unencrypted format, assuming that the network's security measures will prevent unauthorized access. The correct answer is A. Implement logging that anonymizes or pseudonymizes sensitive user data before it is stored or transmitted, while ensuring sufficient detail remains for effective troubleshooting. Explanation. This scenario presents an ethical dilemma concerning data privacy and network security within the context of implementing Cisco video network devices. The challenge lies in balancing the need for effective network monitoring and troubleshooting with the obligation to protect sensitive user data, as mandated by relevant regulations. The engineer must make a judgment call that upholds both technical integrity and ethical responsibilities. The correct approach involves prioritizing data anonymization and minimization while still achieving the technical objective. This aligns with best professional practices and regulatory requirements that emphasize data protection by design and default. By anonymizing sensitive information before it is logged or transmitted, the engineer ensures that even if a breach occurs, the impact on user privacy is significantly reduced. This proactive measure demonstrates a commitment to ethical data handling and compliance with privacy regulations. An incorrect approach would be to log all data without any consideration for privacy, assuming that the network is secure and the data will not be accessed inappropriately. This fails to acknowledge the inherent risks associated with data storage and transmission, and it directly violates the principle of data minimization and the spirit of privacy regulations. Another incorrect approach is to disable logging altogether, which, while seemingly protecting privacy, compromises the ability to troubleshoot network issues effectively and could lead to longer downtimes and degraded service, potentially violating service-level agreements and operational best practices. A third incorrect approach is to selectively log data based on the engineer's personal judgment of what is important, as this introduces bias and lacks a standardized, auditable process, increasing the risk of both privacy violations and operational blind spots. Professionals should employ a decision-making framework that begins with identifying the core ethical and regulatory obligations. This involves understanding the specific data privacy laws applicable to the jurisdiction, in this case, implicitly U.S. regulations given the exam context. Next, they should assess the technical requirements and identify potential conflicts with privacy obligations. The process then moves to exploring solutions that mitigate risks, such as anonymization, encryption, and access controls. Finally, the chosen solution should be documented, reviewed, and implemented with ongoing monitoring to ensure continued compliance and effectiveness. Question 14. The monitoring system demonstrates an unusual spike in bandwidth utilization during peak hours for a specific video conference room. The system logs indicate that the spike is not due to a network fault, but rather an increase in the number of active participants and their video quality settings. The network administrator has the capability to remotely access the video conferencing endpoint in that room to investigate further. What is the most ethically sound and professionally responsible course of action for the network administrator to take? Option A. Initiate a remote diagnostic session on the video conferencing endpoint, focusing solely on network performance metrics and device health, without accessing any video or audio content. Option B. Inform the users of the specific video conference room that their activity is causing a bandwidth issue and advise them to reduce their video quality or number of participants. Option C. Temporarily disable video for all participants in that room to reduce bandwidth consumption and then investigate the cause of the spike later. Option D. Access the video conferencing endpoint to review the live video feed and participant list to understand the exact nature of the increased activity and confirm the source of the bandwidth spike. The correct answer is D. Access the video conferencing endpoint to review the live video feed and participant list to understand the exact nature of the increased activity and confirm the source of the bandwidth spike. Explanation. The monitoring system demonstrates a potential ethical dilemma concerning the privacy of individuals within a video conferencing environment. The challenge lies in balancing the need for network performance monitoring with the right to privacy of participants. Cisco's 210-065 exam focuses on implementing video network devices, which inherently involves managing and monitoring these systems. While the exam doesn't delve into specific legal jurisdictions for privacy laws, it emphasizes professional responsibility and ethical conduct in network implementation. The correct approach involves implementing monitoring solutions that are transparent and minimally intrusive, focusing on technical performance metrics rather than content. This aligns with professional best practices that prioritize user privacy and data security. By anonymizing or aggregating data, and by clearly communicating monitoring policies, network administrators uphold ethical standards and build trust with users. This approach respects the implicit expectation of privacy in communication, even within a business context, and avoids potential breaches of trust or policy violations. An incorrect approach would be to capture and store full video or audio streams for performance analysis without explicit consent or a clear, justifiable business need that outweighs privacy concerns. This could violate ethical principles of respect for individuals and potentially contravene general data protection guidelines that are universally recognized in professional IT environments, even if not explicitly detailed in the exam's regulatory framework. Another incorrect approach is to use monitoring data for purposes beyond network performance, such as employee surveillance, which is a significant ethical breach and likely a violation of privacy regulations in most jurisdictions. Failing to inform users about the monitoring practices is also an ethical failure, as it deprives them of the opportunity to make informed decisions about their participation. Professionals should adopt a decision-making framework that prioritizes user privacy and data protection. This involves understanding the purpose of monitoring, identifying the least intrusive methods to achieve that purpose, ensuring transparency with users, and adhering to organizational policies and general ethical guidelines regarding data handling and privacy. When in doubt, seeking clarification from management or legal counsel is a prudent step. Question 15. The evaluation methodology shows that during the implementation of Cisco video network devices, a network administrator observes unusual data patterns originating from a specific user's endpoint that suggest potential unauthorized access to sensitive information. Though this activity is not directly related to the video conferencing functionality being deployed, the administrator has the technical capability to investigate further and potentially identify the nature of the data being accessed. What is the most ethically sound and professionally responsible course of action for the network administrator? Option A. Directly access the user's endpoint and investigate the observed data patterns to determine the exact nature of the sensitive information being accessed, to better understand the scope of the potential breach. Option B. Ignore the observed anomaly, assuming it is unrelated to the video network device implementation and not within the administrator's direct responsibility to address. Option C. Immediately report the observed anomaly and the potential security concern to the designated IT security team or management, providing all relevant technical details without further personal investigation into the user's data. Option D. Confront the user directly about the unusual data patterns observed, to understand their actions and explain the potential implications of their activity. The correct answer is C. Immediately report the observed anomaly and the potential security concern to the designated IT security team or management, providing all relevant technical details without further personal investigation into the user's data. Explanation. The evaluation methodology shows that implementing Cisco video network devices requires a thorough understanding of not only technical configurations, but also the ethical implications of data handling and network security. This scenario presents a professional challenge because it involves a conflict between a perceived immediate business need and the ethical obligation to protect sensitive user data. The network administrator is privy to information that, while not directly related to video conferencing functionality, could be exploited for personal gain or cause harm if mishandled. The core of the challenge lies in balancing the desire to be helpful or to demonstrate technical prowess with the paramount duty of confidentiality and responsible data stewardship, as implicitly governed by general IT professional ethics and data privacy principles that underpin network device implementation. The correct approach represents best professional practice because it prioritizes ethical conduct and adherence to data privacy principles. By reporting the observed anomaly through the designated channels, the administrator ensures that any potential security vulnerability or misuse of data is addressed by the appropriate authorities within the organization. This upholds the principle of acting in the best interest of the organization and its users, maintaining trust and preventing potential breaches. It aligns with the ethical responsibility of IT professionals to safeguard information and to escalate concerns through proper procedures, rather than taking unilateral action or exploiting privileged access. An incorrect approach of directly investigating the user's activity without authorization would be a significant ethical and potentially regulatory failure. It constitutes a breach of privacy and an unauthorized access to user data, violating principles of confidentiality and data protection. This action could lead to disciplinary measures, legal repercussions, and damage to the administrator's professional reputation. Another incorrect approach, such as ignoring the anomaly, is also professionally unacceptable. It demonstrates a lack of diligence and a failure to uphold the responsibility to secure the network and protect user data. This inaction could allow a security threat or data misuse to persist, potentially causing harm to individuals or the organization. Finally, confronting the user directly without involving the appropriate internal security or management teams is also problematic. While seemingly proactive, it bypasses established protocols, could lead to misinterpretation or escalation of the situation, and may not effectively resolve the underlying issue while also potentially violating privacy and due process. Professionals should employ a decision-making framework that emphasizes adherence to organizational policies, ethical guidelines, and legal requirements. This involves recognizing potential ethical dilemmas, understanding the scope of one's responsibilities and access, and knowing when and how to escalate concerns. A structured approach would involve 1. Identifying the ethical conflict. 2. Consulting relevant organizational policies and professional codes of conduct. 3. Prioritizing data privacy and security. 4. Escalating the issue through appropriate channels, e.g., IT security, management, legal department. 5. Documenting all actions taken. Question 16. Implementation of a new video conferencing solution requires a vendor to demonstrate their product's advanced network monitoring capabilities. The vendor proposes installing their proprietary monitoring software directly onto the production network for a live demonstration, assuring the network administrator that access will be strictly limited to the demonstration period and scope. What is the most professionally responsible course of action for the network administrator? Option A. Agree to the vendor's request, but only after the vendor provides a written guarantee that they will be solely liable for any network issues arising from the demonstration. Option B. Proceed with the installation on the production network, but immediately disconnect the system after the demonstration concludes without further review. Option C. Allow the vendor to install the software on the production network for the demonstration, trusting their assurances of limited access and scope. Option D. Insist on a controlled evaluation of the software in a dedicated lab environment that mirrors the production network, independent of the live production infrastructure. The correct answer is D. Insist on a controlled evaluation of the software in a dedicated lab environment that mirrors the production network, independent of the live production infrastructure. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent conflict between a vendor's desire to showcase their product's capabilities and the network administrator's responsibility to maintain network integrity and security. The vendor's request to install their proprietary monitoring software on the production network, even for a limited trial, introduces potential risks. These risks include unauthorized access to sensitive data, introduction of vulnerabilities, performance degradation, and potential non-compliance with existing security policies or service-level agreements. The administrator must balance the potential benefits of evaluating new technology against the imperative to protect the existing infrastructure and its data. Correct approach analysis. The correct approach involves a structured and controlled evaluation process that prioritizes security and compliance. This means isolating the testing environment from the production network, implementing the vendor's software in a dedicated lab or staging environment, mirroring the production setup as closely as possible, allows for thorough testing without exposing the live network to risk. This approach aligns with best practices in IT security and network management, which emphasize the principle of least privilege and the importance of sandboxing new technologies before widespread deployment. It also ensures that any issues or vulnerabilities discovered during the trial can be addressed without impacting live services, thereby upholding the administrator's duty of care to the organization. This methodical approach also facilitates a more objective evaluation of the software's true performance and compatibility. Incorrect approaches analysis. Allowing the vendor to install their software directly onto the production network, even with assurances of limited access, represents a significant security and ethical failure. This bypasses established change control procedures and introduces an unvetted element into a critical system, violates the principle of defense in depth, and could lead to data breaches, service disruptions, or the introduction of malware, all of which would have severe operational and potentially legal ramifications for the organization. Accepting the vendor's software without a formal security review or risk assessment is also professionally unacceptable. Every new piece of software, especially one intended for network monitoring, must undergo scrutiny to identify potential vulnerabilities, compatibility issues, and compliance risks. Failing to do so demonstrates negligence and a disregard for the organization's security posture. Agreeing to the vendor's requests solely based on their persuasive arguments or the potential for future business, without a proper technical evaluation and risk mitigation plan, is an abdication of professional responsibility. Decisions regarding network infrastructure should be driven by technical merit, security requirements, and business needs, not by vendor pressure or speculative future benefits. This approach prioritizes short-term vendor satisfaction over long-term network stability and security. Professional reasoning. Professionals in network administration must adopt a risk-based decision-making framework. This involves 1. Identifying potential risks associated with any proposed change or new technology. 2. Evaluating the likelihood and impact of these risks. 3. Implementing appropriate mitigation strategies such as isolation, testing, and security reviews. 4. Adhering to established organizational policies and procedures for change management and security. 5. Documenting all decisions and actions taken. In this scenario, the administrator should engage with the vendor to understand the software's capabilities, but insist on a controlled, isolated testing environment. They should also request detailed technical documentation and conduct their own security assessment before any installation is considered, even in a lab setting. Question 17. Stakeholder feedback indicates intermittent high latency on critical video conferencing endpoints, impacting the quality of executive meetings. The network administrator has identified a potential quick fix involving a non-standard CO-S configuration on a core switch, which is not documented in the current network design, but might alleviate the immediate issue. Administrator is considering applying this change to resolve the reported problems promptly. Option A. Advise stakeholders that the latency is a known issue and that a resolution is not immediately available, suggesting they reschedule meetings if necessary. Option B. Investigate the root cause of the latency using standard troubleshooting tools and Cisco best practices for video network CO-S and implement a documented, validated solution. Option C. Apply the non-standard CO-S configuration immediately to resolve the stakeholders' reported latency issues, with the intention of documenting it later if it proves effective. Option D. Reallocate bandwidth from less critical network segments to the affected endpoints without a full analysis of the impact on those segments. The correct answer is B. Investigate the root cause of the latency using standard troubleshooting tools and Cisco best practices for video network CO-S and implement a documented, validated solution. Explanation. This scenario presents a professional challenge because it involves a conflict between immediate operational needs and the long-term integrity of the video network infrastructure, potentially impacting service quality and security. The network administrator is faced with a decision that could offer a quick fix, but might violate established best practices and potentially Cisco's recommended configurations for optimal performance and security, as outlined in the 210-065 exam objectives. The correct approach involves prioritizing the stability and security of the video network by adhering to documented best practices and vendor recommendations. This means investigating the root cause of the latency and implementing a solution that aligns with the system's design and operational parameters. This approach represents best professional practice because it ensures the long-term health of the network, minimizes the risk of unforeseen issues, and upholds the principles of responsible network management. It aligns with the ethical obligation to provide reliable and secure services to stakeholders. An incorrect approach would be to bypass standard troubleshooting procedures and implement a configuration change without proper validation or understanding of its implications. This could lead to unintended consequences, such as introducing security vulnerabilities, degrading video quality for other users, or creating a precedent for ad hoc, undocumented changes that undermine network manageability and auditability. Such actions could violate the implicit trust placed in the administrator to maintain a robust and secure network. Another incorrect approach would be to ignore the stakeholder feedback entirely, assuming the issue is minor or will resolve itself. This demonstrates a lack of responsiveness and could lead to escalating problems, impacting user productivity and satisfaction. It fails to address the immediate concerns of those relying on the video network. The professional reasoning process should involve 1. Acknowledging and documenting stakeholder feedback. 2. Initiating a systematic troubleshooting process to identify the root cause of the latency, referencing Cisco documentation and best practices relevant to the 210-065 exam. 3. Evaluating potential solutions based on their impact on network performance, security, and stability. 4. Implementing the most appropriate solution, which may involve configuration adjustments, hardware upgrades, or further investigation, with proper change control procedures. 5. Communicating the resolution and any preventative measures to stakeholders. Question 18. The risk matrix shows a critical vulnerability in the proposed Cisco video network device deployment related to unencrypted sensitive metadata transmission. The project manager is pushing for immediate deployment to meet a critical business deadline, suggesting that security patching can be addressed post-launch. What is the most ethical and professionally responsible course of action? Option A. Escalate the issue to senior management, highlighting the security risks and recommending a revised deployment timeline that includes security remediation. Option B. Proceed with the deployment as scheduled and prioritize patching the vulnerability immediately after the system goes live. Option C. Delay the deployment until the metadata transmission is secured and encrypted, and then proceed with the launch. Option D. Implement the deployment with a temporary workaround for metadata security, acknowledging the risk but meeting the deadline. The correct answer is C. Delay the deployment until the metadata transmission is secured and encrypted, and then proceed with the launch. Explanation. This scenario presents an ethical dilemma common in IT environments, particularly when implementing new technologies like Cisco video network devices. The challenge lies in balancing the immediate need for a functional system with the long-term implications of security and compliance. The risk matrix, a standard tool for assessing potential threats and vulnerabilities, highlights a critical gap in the security posture of the proposed video deployment. The pressure to deploy quickly, often driven by business demands or project deadlines, can lead to shortcuts that compromise security. The correct approach involves prioritizing security and compliance by addressing the identified vulnerabilities before full deployment. This aligns with the principles of responsible technology implementation, which emphasize proactive risk management and adherence to established security best practices and regulatory frameworks. In the context of the 210-065 exam, this translates to understanding and applying security principles relevant to video networking, such as secure configuration, access control, and data protection. By delaying deployment until the identified risks are mitigated, the IT team upholds its professional responsibility to protect organizational data and infrastructure, ensuring that the video solution is not only functional, but also secure and compliant with relevant industry standards and potential future regulations. An incorrect approach would be to proceed with the deployment without addressing the identified security risks. This could lead to significant breaches, data loss, or non-compliance with potential future regulations, resulting in reputational damage and financial penalties. Ignoring the risk matrix findings demonstrates a lack of due diligence and a disregard for established security protocols. Another incorrect approach might be to implement a superficial fix that does not adequately address the root cause of the vulnerability, leaving the system exposed to ongoing threats. This is a form of technical debt that can lead to more complex and costly problems down the line. A third incorrect approach could be to blame the vendor or the technology itself, without taking ownership of the implementation and security responsibilities. This deflects accountability and hinders effective problem solving. Professionals should approach such situations by first thoroughly understanding the risks identified in the risk matrix. They should then engage in a transparent discussion with stakeholders, clearly articulating the potential consequences of proceeding without mitigation. The decision-making process should involve evaluating different mitigation strategies, considering their effectiveness, cost, and impact on the deployment timeline. Ultimately, the decision should be guided by a commitment to security, compliance, and the long-term well-being of the organization. This often involves advocating for the necessary resources and time to implement security measures correctly, even if it means adjusting project timelines. Question 19. Strategic planning requires a methodical approach to implementing new video network device functionalities to ensure optimal performance and user satisfaction. Considering the potential for network disruption and the need for efficient resource allocation, which of the following strategies best represents a process optimization approach for introducing advanced video features? Option A. Conduct thorough pilot testing of new video features in a controlled environment, followed by a phased rollout to production segments, with continuous monitoring and iterative adjustments based on performance metrics and user feedback. Option B. Implement new video features based solely on the technical specifications and capabilities outlined by the vendor, without extensive user testing or consideration for existing network traffic patterns. Option C. Prioritize the acquisition of the lowest-cost video hardware available to maximize immediate budget savings, assuming current network infrastructure can support the new features. Option D. Deploy all new video features concurrently across the entire network after initial configuration, relying on post-deployment monitoring to address any issues. The correct answer is D. Deploy all new video features concurrently across the entire network after initial configuration, relying on post-deployment monitoring to address any issues. Explanation. Scenario analysis. Implementing video network devices, particularly in a large enterprise or service provider environment, presents significant challenges in optimizing performance and resource utilization. Network engineers must balance the demands of real-time video traffic with other network services, ensuring quality of service, QoS, without over-provisioning or introducing latency. The complexity arises from the dynamic nature of video streams, varying bandwidth requirements, and the need for seamless integration with existing infrastructure. Decisions made during the planning and implementation phases directly impact user experience, operational costs, and the overall efficiency of the video service. Correct approach analysis. Prioritizing a phased rollout of new video features and monitoring key performance indicators, KPI, like jitter, packet loss, and bandwidth utilization is crucial. This approach aligns with best practices for process optimization by allowing for iterative improvements and risk mitigation. By observing the impact of each phase on the network and user experience, engineers can identify bottlenecks and adjust configurations proactively. This aligns with the principle of continuous improvement, ensuring that the implemented solutions are robust, scalable, and meet the defined service level agreements, SLAs, without disrupting existing services. This methodical approach minimizes the risk of widespread service degradation and allows for informed decision-making based on real-world data. Incorrect approach is analysis. Implementing all new video features simultaneously without prior testing or phased deployment introduces a high risk of network instability and service disruption. This approach disregards the need for controlled change and can lead to significant troubleshooting efforts, impacting operational efficiency and user satisfaction. It fails to adhere to sound engineering principles of incremental deployment and validation, focusing solely on reducing the cost of video hardware without considering the impact on performance or scalability is a short-sighted optimization strategy. While cost is a factor, it should not come at the expense of service quality or the ability to meet future demands. This approach can lead to increased operational costs due to performance issues, frequent hardware replacements, or the inability to support advanced video features, ultimately failing to achieve true process optimization. Ignoring user feedback and focusing only on technical metrics overlooks a critical aspect of video service implementation. While technical performance is vital, the end-user experience is the ultimate measure of success. Neglecting user input can lead to solutions that are technically sound but practically unusable or frustrating for the intended audience, representing a failure in holistic process optimization. Professional reasoning. Professionals should adopt a data-driven and iterative approach to process optimization. This involves clearly defining objectives, identifying key performance indicators, planning for phased implementation, continuous monitoring, and incorporating feedback loops. When faced with complex implementation scenarios, a structured methodology that prioritizes risk assessment and mitigation, alongside performance validation, ensures the most effective and sustainable outcomes. Question 20. Investigation of a corporate network experiencing intermittent video conferencing quality issues, characterized by pixelation and audio drops, prompts an evaluation of process optimization strategies. The network utilizes Cisco video endpoints and infrastructure, which approach best addresses the root cause of these performance degradations while ensuring overall network stability. Option A. Increase the overall bandwidth allocation to the network segment hosting the video conferencing servers without analyzing traffic patterns. Option B. Disable advanced video features such as high-definition resolution and screen sharing for all users to reduce bandwidth load. Option C. Implement a comprehensive quality of service (QoS) policy that prioritizes video traffic based on application type and user group, coupled with traffic shaping to manage bandwidth consumption. Option D. Immediately upgrade all video conferencing endpoints to the latest models to leverage newer, more efficient codecs. Correct answer is C. Implement a comprehensive quality of service (QoS) policy that prioritizes video traffic based on application type and user group, coupled with traffic shaping to manage bandwidth consumption. Explanation. This scenario presents a common challenge in network operations, optimizing video traffic flow to meet user experience demands while adhering to network resource constraints. The professional challenge lies in balancing the immediate need for improved video quality with the long-term implications of network stability and efficient resource utilization. A hasty, unanalyzed approach can lead to unintended consequences, such as increased latency for other critical services or excessive bandwidth consumption that impacts overall network performance. Careful judgment is required to select an optimization strategy that is both effective and sustainable. The correct approach involves a systematic analysis of video traffic patterns and network performance metrics to identify specific bottlenecks or areas for improvement. This data-driven methodology ensures that optimization efforts are targeted and address the root cause of any degradation in video quality. By understanding the specific characteristics of the video streams, e.g., codec, resolution, frame rate, and their interaction with network protocols and devices, engineers can implement precise configurations. This aligns with best professional practices by prioritizing evidence-based decision-making, minimizing disruption, and ensuring that network resources are used efficiently. The focus is on proactive problem-solving and continuous improvement, which are hallmarks of professional network engineering. An incorrect approach might involve broadly increasing quality of service (QoS) priority for all video traffic without understanding its impact. This could lead to other essential traffic types being starved of bandwidth, potentially violating service-level agreements (SLAs) for non-video services and causing broader operational issues. Another incorrect approach could be to simply upgrade hardware without a thorough analysis, which is often a costly and inefficient solution if the underlying issue is configuration or traffic management. A third incorrect approach might be to disable certain video features or codecs to reduce bandwidth, which directly impacts user experience and could lead to customer dissatisfaction and potential breaches of service expectations. Professionals should employ a decision-making framework that begins with clear problem definition, followed by data collection and analysis. This includes monitoring network performance, analyzing traffic flows, and understanding application requirements. Based on this analysis, Potential solutions should be evaluated for their effectiveness, cost, and potential impact on other network services. Implementation should be done in a controlled manner, with thorough testing and monitoring to validate the results and make any necessary adjustments. This iterative process ensures that optimization efforts are successful and contribute to a stable and high-performing network.